I'm Anil Kumar, and this video is for my student Maria. Maria, thanks for sharing these questions with me. I'll provide you with all the solutions. Remember this type of question you could find in my folders on application of rational functions and also under application of quadratic functions. The question here is, at her usual rate, a woman travels 60 miles by car in a certain amount of time. If she increases her usual rate by 10 miles per hour, she could travel the 60 miles in half an hour less. Find the usual rate. So our strategy is always make a table with distance, speed, and time. You know their relation. Distance is speed into time, right? So that should help you to solve the question. Now here, what we have is, we have that a woman is traveling and she covers a distance which is fixed distance of 60 miles. So we have these three columns. We'll say distance, speed, and time. Distance here is in miles, so write down the units. Speed will be in miles per hour, okay, and time is in hours. So that is first thing. And then we will say usual rate and faster rate. So let's say usual rate and faster rate. So just define your variables, kind of make a matrix, right? Once you have a matrix like this, fill in the values which you know. Read the problem once again. It says at usual rate, that means under this column, woman travels 60 miles by a car in a certain amount of time. Now this time you don't know, okay. If she increases her usual rate by 10 miles per hour, that means faster. It becomes 60 plus 10. If she increases her usual rate, rate is speed which is not known. So let us say this speed is s for you. And if she increases the usual rate by 10 miles, then means s plus 10. 10 miles per hour. She could travel 60 miles, so distance is same, 60 miles in half an hour less. So this time is, if this time is t, then this time is t minus half. So that is the kind of relation which you could make. And now the question is how to form an equation, right? So that is the second part. For that, we have to look into the relation between distance, speed, and time. Now you know how they are related. Let's make our triangle. Distance, speed, time, triangle. Okay, so that is a distance, speed triangle, where distance is equals to speed into time. Now since we know that time is half an hour less and we know the distance, it is good to write relation with time, correct? Because there are two variables. So this is the judgment which you need to make, and that is where sometimes you may get confused, right? So we'll see how much time will this woman take to travel with usual rate. Time will be distance divided by speed, right? So that time is equals to 60 divided by s. And if the speed is higher, this time will be 60 divided by s plus 10. And difference between these two time is half an hour. That is what it means. She takes longer with lesser speed. And so you get your equation. That is 60 over s minus 60 over s plus 10. So when you divide by a bigger number, you get lesser amount, right? So you get here difference is half an hour. So that is how you get your equation, correct? So once you have equation, you can take common denominator and multiply. Okay, so let's do that. So we have to multiply, or you could also simplify this equation a bit. That is to say, we can take 60 common, or let's not do that. Let's straight away multiply. Okay, so we have this as 60 times s plus 10, and also by 2, because the common denominator, what are we multiplying by? we are multiplying by everything in the denominator here. It is 2 times s plus 10. So when you multiply the first term, s and s cancel. So it should get multiplied by 60 times s plus 10 times 2, right? Minus, this will be multiplied by 60 times s times 2 equals to, here you will get s times s plus 10. Correct? That is how you should be doing. At times, to make it simpler, you can actually take 60 common. 2 times 60 is 120. But I'm not going there. I'm just keeping it simple at present. Now expand it. So 60 times 2 is 120. Multiply both the numbers by 120. So you get 120s plus 120 10 minus 120s equals to s square plus 10s. Now you have a quadratic equation, and that is the reason you might see similar examples in quadratic functions applications. Bring all the terms to one side. So we have s square. Amongst s we have 120s minus 120s, and that is 0. So we are left with 10s only. So we are plus 10s. We are bringing everything to the right side. And amongst the numbers, we have 1200 minus 1200 equals to 0, right? Now that is a quadratic equation which you can use quadratic formula to solve, or you can also factor, right? We'll prefer to use, you can do 40 times 30, right? 40 times 30 is 1200, correct? And if you find the difference, 40 minus 30, then what do you get? 40 minus 30 is 10. And therefore, we can factor this as s plus 40 times s minus 30. Well, in test, you may not, get this factoring. In that case, you can use quadratic formula, right? Let me write down the quadratic formula for you. You can say s is equals to minus b, which is minus 10, plus minus square root of b square, which is 10 square, minus 4 times minus 1200. So 1200 I'll write positive, but make this divided by 2 times a. You can use this formula, find the answer. Well, we factored, so we can now write down the answer from the factors. S plus 40 is 0 for s equals to minus 40, and that is not real. Okay, and here the speed s is equals to 30. So 30 is our positive speed. Speed we are taking as a scalar quantity, so therefore we'll go with the positive number, correct? So the answer is that her usual speed, which is s defined for us, is 30 miles per hour. So the answer is usual speed is 30 miles per hour. So that is how you can answer this question. I hope that helps. Thank you and all the best.